Okay, let's take a look at how to deal with inequalities when they show up in what we would consider a linear function, or a linear equation. So over here we have this thing that says y is greater than negative 2x plus 5. Well, the first thing I want you to do is think back to your graphing techniques. Let's just not worry about the greater than sign. Just pretend it's not even there. Let's see if we can graph y equals negative 2x plus 5. This will give us what we call our boundary line. Now I'm going to remind you of a couple of things. This number negative 2, that tells me the slope, but it really has a 1 underneath it. We never seem to write that, but that gives us good instructions on how to graph something. So if I graph this line, the 5 tells me where it crosses the y-axis, and the negative 2 tells me it's a negative slope, and it goes down 2 over 1. Down 2 over 1. So I have this straight line that's going diagonal, and it's going to the negative slope just like it says it should. And what I'm going to do now is I'm going to draw that boundary, but I'm going to draw a dotted line instead of a solid line. Now it's not always that way, but in this case I'm going to look back at this right here and remind myself that there's no equal to portion here. What I'm really trying to find, this is hard to put into words, is I'm trying to find all of the x and y coordinates. There's one right there. There's a whole bunch of them. There's an infinite amount. All the x and y coordinates that happen to work in this particular inequality. Okay, and there's points all over the place. What we're going to find is either all the points on the left, like the green point, those work, or all the points on the right, like the orange one, those work. And the ones that happen to lie right on this line, so if I have a point right on this line like that one, it's not going to work because I don't have an equal to portion there. Okay, there's no equal to underneath my greater than sign. So basically, here's the pattern. If I have a greater than or a less than, it's going to be a dotted line. If I have a greater than or equal to or less than or equal to, it's going to be a solid line. So those are the things you need to recall. Now, we basically got our graph down. Nothing new here other than the dotted or solid line. The last thing we need to figure out is, do the orange points, all the ones over on the side where the orange one is, do those work in this inequality? Or is it all the green ones over here that work? And the way you do this is you're going to pick one point, any point you want that's not on the boundary, and test it out mathematically in the function. Now, what that means is you need to be strategic in this. Okay? I'm thinking, what are the easiest possible numbers I can use to interpret this? When you're doing calculations, what's the easiest number you ever pick to use? And my answer would be 0. How about 0, 0? Now what that shows me, if I pick 0, 0, that's the origin right there. If I'm going to test that out, I'm basically testing all of the green points. Any point that's over on this side, I'm checking to see if 0, 0 works, then any of these points on the left side where all the green ones are would work. So let's see what happens. Go to your original problem, okay? Ignore all this stuff now. That just helped you get the boundary line. Let's go back to our original problem. Y is greater than negative 2x plus 5. Okay, what I'm going to do is I'm going to plug in 0, 0. That means 0 for x and 0 for y. And I'm just going to see what it tells me. 0 for y and 0 for x, and all the other numbers stay the same. Now let's just see what this tells us. Negative 2 times 0, well, that's still 0. So I get this statement that says 0 is greater than 0 plus 5. I want to know, is that true or is that false? Okay, when I look at that, 0 is greater than 5? No, that's not true. Okay, that is not true. That's a false statement. Now what that means is 0, 0 did not work. It does not work in my function. So 0, 0 is not a solution. That means none of these points over here are solutions. Nothing on the green side works. So it must mean my solutions to this problem must be on the other side, so I'm going to shade this side to say any point over on the right side is going to be my solution set. Okay. Now if I had tested out 0, 0 and that happened to work and give me a true statement, then I know that everything on the left side happens to be a solution, so I would shade the left side. So it's all about interpretation. You have to think your way through this problem. This isn't one you could just jump in and have the answer pointed directly towards you. You have to sit back and process what point you picked. And in my case, I would say always pick 0, 0. That point you picked, what did it say? Did it say it works in this inequality, or does it not make any sense? And if it doesn't make any sense in an inequality, then it's probably not a solution.